We're going to take our rational expressions and create equations with them. This lesson, I'm going to warn you, can get very complicated. So if you are confused and you need a little more help with this, that's totally okay. If you don't, then I give you the right to end this lesson feeling like a genius. One way to solve a rational equation is to use cross multiplication. So let's look at the first example. Remember, when you cross, you multiply diagonally. So you get 5 times x minus 4 equals x plus 4 times 4. You must write all this out. There is absolutely no way you're going to get this right. It's too much to store in your head if you're not writing it down. So this gives me 5x minus 20 equals 4x plus 16. Okay, no big deal. That's from chapter 1. Drop a line. I'll do variables on the left. Minus 4x. Oh, that didn't cancel. This canceled. I get 1x minus 20. I was so eager to cancel. And then add 20 to both sides. X equals 36. And that's it. Letter B. Cross multiply. And you get 35 equals y times y minus 2. That is 35 equals y squared minus 2y. Don't forget from chapter 7, in order to solve this, we have to make it equal to 0. And now let's factor. That is negative 7 plus 5. So this is going to give me y equals 7. This will give me, whoops, not x, y. Y equals negative 5. Okay, all right, no big deal. Let's see what happens when you don't have the easy opportunity to cross multiply. This is going to combine what we just did in the last lesson where we had to get a common denominator. So you're going to multiply each side by the LCD. Now, you could get a common denominator and combine this left-hand side and then cross multiply. You can do that, but I want to just show you another way. So the least common denominator of these three is 3 times z minus 2. So I'm going to multiply each term by 3 times z minus 2. So that's this term. That would be this term. I know my z's look like 2's, sorry. And this term. So here we go. Remember, it's 3 times z minus 2 over 1. So I'll write it out. 3 times z minus 2 over 1 times the first term. Minus 3 times z minus 2 over 1 times the second term. Equals 3 times z minus 2 over 1 times the third term. And now you just keep going. So this first term gives me, well, I can cancel first. So this gives me 3z. Yeah, over 1, whatever. Minus, the 3's cancel here, and I'll have z minus 2 times 2 over 1. And here, the z minus 2 cancels, so I get 6 over 1. So it's looking a little better. And luckily, since these are both over 1, I can just combine the numerators. So I get, well, let me do this math. This is 2z minus 4. So now I have 3z minus 2z minus 4. Oh, nope, no I don't. Because I have to distribute the minus sign. So it's minus 2z plus 4 over 1 or whatever equals 6. Almost there, almost there. Combine your terms, you get z plus 4 equals 6. And when you do your inverse, you get z equals 2. So you go to circle it, and you're like, yeah, I got it. But then you look up here, and z is not allowed to be 2, because if z were 2, it would be undefined, because you get a 0 in the denominator. So we did all that work. Z can't be 2, so there is no solution. What a bummer. So don't just circle your answer and think you're done. You always have to go back up and check to make sure it works. Pause the video and read example 4. So when you start, the deck contains 17 out of 50 creature cards. But you're adding some mystery number of creature cards, which not only increases the number of cards, the creature cards, but also increases the total number of cards. So the proportion is the ratio is 17 plus x over 50 plus x. That, it tells you, you keep doing that until it equals 50%, which is the fraction 1/2. So now this one we can just easily cross. So you get 17 plus x times 2 equals 50 plus x. That is 34 plus 2x equals 50 plus x. Drop a line. Variables to the left. Minus x. 34 minus x equals 50. Plus x, sorry. Minus 34. X equals 16. So that means that you added 16 creature cards. If you have any questions, write them down and ask me when you come to class.